This is a section or a presentation on networking devices. And what we're going to be talking about are some of the basic or common network devices, connectivity devices. And then we'll talk about some other specialized devices. Now, I'm going to give you kind of an overview. In some cases, the devices I'm talking about are very basic, and there's one flavor of them, and that's it. In other cases, as we start to get into some of the more complex devices like firewalls, intrusion prevention and detection, those are very complex things. I'm going to try and describe them to you at a high level, and but depending on what you're looking at, what kind of device, there's going to be slight variations. So it's not like what I'm going to describe to you is the be all and end all. There's a lot of detail that you can drill into, but understanding it at the level that I'm going to describe it to you at is perfect. This is the level you need to understand it at, unless you're going to go, specialize in networking and network devices. But this will help you with whatever stream you're going to continue pursuing. All right, so we've already talked about the NIC or the network interface card or network interface controller. Sometimes it's called, some people call it a LAN adapter, physical network interface, lots of different names, but most people you'll see will refer to it as a NIC. And so NIC is a layer 2 device, as we talked about. It's got a unique MAC address, globally unique, that's used by other network devices to find a particular device. Okay. When you go back, and again, I don't know how old all of you are, but when I first started working with computers, this is what NICs used to look like. You'd have this slot here, and you'd open up the computer. Most of us had desktops at the time, which are the boxes. You open up the box, you slip this card into the bus. There was an adapter, the female equivalent of this, that this would plug into, and then you close the cover and then plug in the Ethernet cable here. Nowadays, a lot of the network interface cards are built right into the motherboard. You never have to look at one, change one, see it. It's a lot smaller than they used to be, but at the end of the day, they all have to have this interface to be able to allow for an Ethernet cable if you're using Ethernet. But of course, if they're wireless, then it's got some kind of a wireless transmitter. Okay, so this is a network interface card exists pretty much on every single device that you're going to work with, because that's what's going to allow you to then connect to a network. Okay. Main thing here to remember is that it's got a unique MAC address. Okay, what's a hub? So a hub is about the dumbest device you can think of the second dumbest device you can think of on a network. Imagine if you have two computers, right? And you're just trying to create a network between two computers. I can just run the cable from theoretically, I can run the cable from one computer to the other computer, right? But you remember, what was one of the things that you saw about the cable specification? What was one of the properties that you saw about the cable specification that I showed you earlier? You recall something that would cause a problem? Anybody on Slack? Not duplex, not the. So I'm connecting two computers. They're this close. Then I move them further and further and further. And at some point, what's going to happen? The cable is only spec'd for the cable length. The cable is only spec'd, the protocol is only spec'd for a particular length of cable. Because what happens to electrical signals over the course of space is that they degrade. Okay, so they're not going to remain as strong beyond that specification. So what if I had two computers, those two devices that we're imagining, let's say they're 50 feet apart, I can put one cable, run the one cable between the two of them. But let's say I move them 200 feet apart. Well, what I need to do then is between those two computers, I need to put a repeater. So the repeater is actually the dumbest network device, because all the repeater is going to do is just going to strengthen the signal. So it doesn't know anything about what that signal is. It doesn't know what it means, where it's going. All it knows is that, you know, it needs to be 5 volts, and I'm just going to boost it up to 5 volts because it's dropped to something lower. Okay, it's going to make that one a one again, a proper one. So that's what a repeater is. Now, a hub is nothing more than a multi-port repeater. So essentially, every connection that comes into here, right? So now if I've connected these two computers and I need to connect another one, another two, and another two, and another two, I can't just keep connecting these computers to each other. It doesn't scale very well. So the better way to do it is to connect all of these computers into a hub. Okay, so what happens is all the traffic from one that's sent out by one host or one device is then transmitted, and it's just sent back out by the hub to all of the other hosts. Okay, so all of the traffic coming in from one host that's destined for some other host gets sent to every other host on that hub. It's just a repeater with multiple ports. Okay, so if we think back to our collision domain, okay, what is this? It's got a huge collision domain, right? Because every packet is being sent to every computer, and the chances of collision increases significantly. So this is probably something that you have at your house. In some cases, it might be something that you have in your office if you've got a small office, but it's really most suited for a very small LAN. The other thing about a hub is that it is not secure. I can basically plug another computer, excuse me, plug another device into here, and if I knew how to write the software, I could basically intercept all of the signals coming in, because they're all coming to me anyway, and I can decipher them, right? So they're not secure at all. And on top of that, as I mentioned, everything is sent to every other machine. So there's no routing capability. I can't say this signal or this message is destined for these computers or this computer. It's just boom, sending everything out to all of the computers. And as we mentioned before, this is all half duplex. You can only put one message on at a time. Okay, so it has its places, small LANs, but just remember, security concerns, lots of collisions, and it's only it has no routing capability, so everything gets sent to everybody. Okay, so that's what a hub is. Yeah, and so a hub is operating at what layer? Layer, not at the data link layer. It's basically just repeating. It's acting at layer 1. It's just retransmitting a signal at the physical layer, correct? Okay. It's not, doesn't know anything about the signals or the packets. Okay, so that's a hub. Then you have a switch. Okay, so a switch is actually, before I get to a switch, let me do the bridge. Okay, so a bridge has exactly two ports, one on the left side, one on the right side. Okay, and what it does is it divides a network into two. So by dividing the network into two, what have I done based on what we talked about before? I have reduced my collision domain, right? So if I take away this bridge and instead I just put one hub and I connect all these 4 to one hub, then all the messages sent by those 4 hosts have the potential to collide. Now what I've done is I've put in a bridge, left and right, and on each side of the bridge, I have a smaller network. So the bridge knows which hosts are on the right side and which hosts are on the left side. Okay, so it's working at layer 2 this time. So if there's traffic that needs to go from host A to, let's say there was another host here, let's call it B1, and another one here called A1. So let's say there's traffic that's put on this, sent out from this host, and it needs to go to B. Because this is a hub, it would go to B, it would go to A1, and it would go to B1, right? But it's going to be restricted here. The bridge would be smart enough to know that that host that it's going to is not on this side, and it's not going to send traffic to this segment here. And so all of the traffic stays here. Now, if host A wanted to send something to host D, the traffic would come through here, come through the hub. It would definitely go to host B because a hub is just repeating. It's just retransmitting. It would go to the bridge. The bridge would say, yeah, host D is on that side. So it's going to transmit, and then it would go to host D. But in this case, because there's a hub here, it's also going to go to host C. Okay. So that's a bridge. All right. So it's a little bit smarter. It works at layer 2, so it's forwarding the Ethernet frames, and it's going to block traffic from going when there's no need for it to go to the other network. So it's a good way to segment your network. Okay. And actually, that brings us to a question, and maybe we should have talked about this before. We did talk about it a little bit in terms of collision domains, but why do I want to segment my networks? Like, why don't I want a hub? Well, yeah, we talked about the collision domain, right? We don't want collisions. We don't want our network to become overloaded. So when we talk about the Ethernet protocol, if every device is putting messages on the bus or on the physical wire, and I can only have one at a time, I want to limit that. So I want to segment my network for that reason. The other reason is potential security, right? So I want this. I've got highly secure devices over here, highly sensitive data. So I want this network to not be able to connect directly to that network, only based on some specific access rules and so on and so forth. So performance or bandwidth congestion is one, and then security would be another one. Okay, and then you might also have maintenance, right? You might have different teams responsible for maintaining networks. And so, if you can split up the networks, it allows you to do maintenance or troubleshooting on those specific kinds of networks. You might have different departments. You might have different types of networks, right? We talked about the different topologies last time, but you might have 2 different companies that merged, and they have 2 different kinds of networks, and you really can't connect them except you have to keep them separate. You can only connect them with one of these devices. So there's lots of reasons, good reasons, to keep networks separate. And then these are the devices that are going to help you connect them. Okay. So the hub so we have the repeater, which is the dumbest device. It's just amplifying or repeating the signal. Then you've got the hub, which is a multi-port repeater. It's just going to repeat the signal, but to multiple ports. Okay. Then we have the bridge. The bridge does a good job at layer 2 of segmenting the network. It won't pass packets or frames onto one side of the network that don't need to go there. So it'll keep the network segmented that way. Okay, so let's talk about the switch. So a switch is used when you want to connect multiple subnetwork or multiple hosts that are on the same network. Okay, so it's also going to work at the data link layer. So unlike the hub, this one is working at layer 2, which is more like the bridge. And basically, it's going to receive traffic, and it's going to forward the traffic only to the recipients, unlike the hub, right? And also unlike the bridge. The bridge is sending the traffic to that entire segment of the network, right? Whereas a switch can direct traffic to a specific host, right? So it's slightly different. So you can look at it here. The interface kind of looks like what the hub looked like, but what's happening is it's intelligent. So in this case, when this device here, this host here is trying to send a message to this host, it comes in through the switch and it gets transmitted only to the host that it needs to go to. How does the switch know what host to send it to? Bada bing. Okay, good stuff. You're all listening. Because of the MAC address, it's working at layer 2. Layer 2 inspects the MAC address. So it looks at the MAC address and says, okay, you want to send it? I know where this MAC address is, and it sends it to that particular MAC address. Okay. So essentially, how many collision domains have I created here? 1, 2, 3, 4, 5. So essentially, each pair is its own collision domain, right? So I've gone from one huge collision domain. Now, the only time traffic is going to collide is when two hosts that are talking to each other are trying to put traffic on the same wire, or two hosts are trying to talk to one particular host, right? Other than that, you've reduced the amount of collisions that are going to happen. And you also have the ability to have full duplex here. And by the way, with full duplex and half duplex, you also need different type of cabling. So you need some additional twisted pairs. We saw those 2 pairs. You need a 4-pair wire, but you can do full duplex. Okay, so the hub works on layer 1. The switch and the bridge work on layer 2. The switch is intelligently, if you will, directing traffic to a particular host based on MAC address, whereas the bridge is directing traffic to one segment. Bridge has exactly 2 segments. So it's going to either block traffic or allow traffic. That's simple. Okay. All right, so we talked about the okay. A router is going to, so think about a switch as connecting hosts on a single network, okay? A router is going to connect hosts on different networks. So you have a school network and a home network, right? Or let's say a department, one department and another department. It's going to connect devices on these different networks. A WAN, exactly. Okay, it's going to allow you to create a WAN as opposed to a LAN. Okay, and the way it's deciding, okay, it's not using MAC addresses, but it's using IP addresses. And where do IP addresses play a role? They play a role on layer 3. Okay, so a bridge and a router work at layer 2. The router works at layer 3. Okay, and so what a router is doing is it is taking the IP address, and a router has within it what are called route tables. And some of these route tables are built automatically. Some of these route tables are built manually or statically. But essentially, you tell it where you want to send the packets. So if a packet is destined for some other, some particular place, you have to tell it where to send it to maybe to another router here, or to this router over here, or to that router over there. So you have to kind of create a route table. But the main thing is it's joining together disparate networks. So you're going from a LAN to a WAN. Okay, and it's typically a hardware device, but it's got some very sophisticated software that's built into it in order for it to work properly. Okay. All right, so far we've talked about devices that are essentially passing traffic through, right? Except for the bridge, maybe, where there's a little bit of blockage based on the MAC addresses. Generally, we're talking about how do we get traffic to go through a particular device. Now we come to a firewall. Most of you, if not all of you, have heard about firewalls. Firewalls are security 101 as far as networks are concerned. Okay, it's kind of your first point of defense as far as your network is concerned. So if you look at this image here, for example, okay, here is my internal network, okay, where I've got various kinds of devices. And what sits between all the devices on my network and everything outside is this firewall. All right. And it's going to essentially block traffic based on certain criteria. This is now where, and I'm hesitating a little bit because I'm trying to figure out how much level of detail to go in. But network firewalls, they're different types of network firewalls. In fact, now you'll hear people talk about these things called NGFW, next generation firewall, and it does so much more than some of the traditional firewalls. But essentially, in a firewall, you put it at the what's called at the tip of your network or at the perimeter of your network, and then you provide it with firewall rules. And those firewall rules historically have been port and protocol based. Okay, so port and protocol was what? What layer? You remember where port and protocol were? So we had MAC address, we had IP address 3, and then at the transport layer, which is layer 4, we had port and protocol. And the protocol might be TCP or UDP, correct mine? And then the port can be anything from 0 to 65,000. So historically, firewalls would allow you to say, okay, specify port, protocol, but also IP. So layer 4 and layer 3. So it would say, for example, allow traffic on port 80 from, let's say I'm running a website, right? I need traffic on port 80 to come in from anywhere because that's the port on which websites work. So it would say any IP address, allow port 80. But if somebody's trying to log into this computer, and usually we log in on port 3389 or port 8 or port 22, then we would say for port 22 and port 3389, only allow access if the IP address is in this certain range, which would be correspond to somebody who's on some kind of a VPN. Okay, so it's going to allow you to specify port, protocol, layer 4, and then IP at layer 3. Okay, and by specifying that, you are going to essentially prevent unauthorized access to your network. Okay. And the most efficient firewalls are the kinds of firewalls that you see here. So they're very specialized, specifically created appliances, which, I mean, they're essentially servers, they're computers, but they're specially crafted to do what they want, what they're supposed to do with high-powered processing chips, plus very specific software. But you can also have a software-based firewall. So I can take just a regular server, and I can put some specific firewall software on it, and I can connect it to the network perimeter, and I can make that behave like a firewall. So that will also behave like a firewall, but typically it's not going to be as efficient as this. So you won't be able to get, this will basically slow down traffic. So you won't get as much traffic through. This will cause a bottleneck. So the more traffic you're getting, the more of an efficient firewall you need, a more powerful firewall. Okay, so we talked about repeaters, hubs, just basically amplifiers. We've got a bridge that connects two segments of a network. We've got a switch that intelligently connects inside your network, multiple devices. Then you've got a router, which allows you to connect multiple networks, create a WAN, okay? And then the firewall is actually a protection device. So it's very different than the other devices that we were talking about before, where those are trying to efficiently get traffic across. This is trying to make sure that there's no unauthorized traffic. So a very different kind of function here. And this is going to operate, and this is where I was saying, I was hesitating a little bit because I said it operates at layer 3 and layer 4. That's not always the case. The newer firewalls now operate at layer 7. So it will actually inspect the data packets that are coming through at layer 7 and do some very intelligent processing there. So I would say classically, the firewall operates at layer 3 and 4. Newer firewalls are going to operate at layer 3, 4, and 7. We won't get into, well, we will get into layer 7 in just a second, but yeah, I would think about firewalls as at layer 3, 4, and 7. So port, protocol, IP, and then data inspection. So the data inspection, this is called intrusion detection system or intrusion prevention system. IDS and IPS are normally modules that you add onto a firewall. So, you know, the hardware is there. You just tell the manufacturer, okay, I want to purchase this module, and they enable this module for you, and or you enable it, you pay for it, and now all of a sudden you have intrusion prevention and intrusion detection. What intrusion prevention and intrusion detection is doing is it is inspecting not just the port, protocol, and IP, but without getting into too many complications, essentially it is looking at the data packets. Okay, so you remember I told you before that all of this traffic flows through and the data packets are only inspected by the data is only inspected by the layer at which it's where it's responsible. So the frame would be inspected at the Ethernet level, then it passes up, and then that's inspected by the layer 3, and then it's passed up, it's inspected by layer 4. But these IDS and IPSs, their next generation firewall, they actually do what's called deep packet inspection. So they will inspect the data because sometimes there's malware in the data and the application wouldn't be able to detect it. And so the firewall is going to do that detection. It's going to say, oh, I see a virus in this packet, and it's just going to drop the packet. It's going to probably drop that connection as well, but it will do deep packet inspection. Okay. It will also, it also does what's called stateful packet inspection. Means it not only inspects the packet, but it knows the context of that connection. So let's say, you know, some device is sending information, and based on that context that it's getting, it knows it's a chat application, or it knows it's something else. So, you know, it might allow things through because it knows it's a chat application, right? It might allow you to send some, you know, funny characters or messages that otherwise would be suspicious. But if it's some other user connected, let's say, to a database, then it will look at, you know, special characters and odd-looking messages, and it'll say, hey, this kind of message is not appropriate for this kind of application. It's potentially malware. So intrusion prevention and intrusion detection is advanced analysis, if you will, advanced analysis of the data packets based on the two applications that are talking to one another. So definitely when you get into IDS and IPS, you're talking, layer 7, and then there's going to be layer 4 and layer 3 baked into that as well. Okay, and an IDS IPS, you typically can't buy an IDS IPS by itself. It's, like I said, it's going to be a module that comes in as part of a firewall. And in fact, today they're called NG-FW, so next generation firewall. Even though it's the current generation, it's called a next generation firewall. And you get an IDS IPS module, you turn it on. And by the way, it's not so easy as just turning it on. You actually have to write a lot of rules, or you have to use the manufacturer's rules. The manufacturer has what they call threat intelligence that will help it decipher what are bad IPs and bad traffic and things like that. So it's quite complex. You have to use or create these rules, and there's a special language in which you have to write these rules, but all those rules get downloaded onto the IDS IPS module, and then you're just that much more protected from threats. Okay, so next generation firewall is going to protect based on, a basic firewall is going to protect you based on port, protocol, and IP. And then once you add IDS and IPS, you're going to start seeing additional protection at layer 7 as well, with quite a lot of, how should I say this, intelligence, and using quite complex algorithms. Okay, so it's sufficient for you to know that a firewall is protecting you based on port, protocol, and IP, and IDS and IPS is protecting you based on advanced logic, advanced deep or deep packet inspection. If you understand it to that extent, that's more than enough for you to know. All right, let's go into some other network devices that you're going to run into. Let's start with a load balancer. A load balancer does exactly what it sounds like it does. It balances load. All right, how can I explain this? So let's say, for example, I have a server. That's my web server, right? So you guys all know, I think, and if you don't know, I'll take this as the first explanation, that in order to run a website, you have a server. On that server, you install a web server, and in that web server, you install all your files that are your website file, your HTML, JavaScript, and all of that. And then somebody from the outside will access that web server. You give them the IP, they access that web server, and a web page pops up. So if you start with that basic scenario, I've got one web server and one person accessing it, no big deal. Now 2 people, now 3, now 10, now 20, now 40, 400, 1,000, 10,000. All of a sudden, your web server can't take the load anymore. It's too much. So how do you solve that problem? Well, you solve that problem by putting in place, instead of one web server, you put in 2 web servers, let's say. But how do you decide, like, how do you tell the person who's going to access your website, well, you can access this IP or that IP? Well, you don't. You just give them one IP. The IP you give them, and you actually give them the URL, just like you guys see, you go to google.com, but google.com will point to a load balancer, okay? And that load balancer will then decide, okay, this server here has 10 requests pending, this server here has 5 requests, so I'm going to send this new request here. Another one comes in, goes here, and then another one might come there, another one might go here. So it takes the load that's being asked of the web servers, and it distributes it between those 2 web servers. Now I can add 4, 10, 20, 100. I can just keep adding web servers. It scales linearly. I can add as many web servers as I want. And I just put a load balancer in front of it, and I can just be able to handle more load. Okay, so a load balancer distributes the load associated with a server onto a number of different servers. Obviously, you have to have those number of servers deployed and commissioned, but the load balancer is going to allow you to distribute that load across the different servers to be able to meet the demand. Okay, and again, what it's showing here is you can have a software-based load balancer or a hardware-based load balancer. Okay, hardware is a specific, it's known as an appliance often when they say I've got a hardware firewall or a hardware load balancer, people will refer to it as an appliance. So it's nothing more than a very specifically designed and specific purpose-built hardware with software on it, whereas a software load balancer would be any generic server that you buy and you put specialized load balancer software. But again, anything that you put on a generic server that's software-based is not going to be as efficient as an appliance, but it'll also be a lot less expensive. So it depends on what your needs are. Okay, so I talked about going to a website, and I said, well, you're going to give somebody your IP. Well, you're not going to give anybody your IP. That would be silly. Nobody gives you an IP. When do you use an IP to go to a website? Never. What you actually give somebody is a URL, like www.clarusway.com, www.google.com, you name it. You guys all know what URLs are. At which layer that we've talked about so far, at which layer does the network communicate via URL? In which diagram did you see URLs at layer 3? Which layer or which diagram did you see at layer 2, layer 4? Where did you ever see URL on that network communication diagram? Nowhere. Networks know nothing about URLs. Okay, a URL is a URL. That's it. Networks only know IP addresses, MAC addresses. Okay, so in order for you to go from URL, which is for humans, because humans can't remember, we're going to remember an IP, to go from a URL to an IP, we have what's called a DNS server, a domain name service server. DNS, very important. Okay, DNS servers will convert a URL into an IP. So you don't have to remember the IPs. Okay, so when your web browser wants to go to a particular site, you type in www.mysite.com. The first thing that browser does is it makes a query to a DNS server. So it has the address for a DNS server. It'll make a query to a DNS server, and it will say, somebody just typed in clarusway.com. Can you tell me which IP address that is? And sometimes it'll get back one, sometimes it'll get back many, depends on the way the DNS server is set up. But you're going to get an IP address. Once it gets that IP address, now you're back to layer 3 and 4, right? So now you've got the IP, the port, protocol, and you're able to now go down that communication channel, those layers, with the protocol, the port, the IP, then you'll get the MAC address, and then you'll go all the way down to physical layer. All right. And by the way, the more you talk about this, the more you start working, depending on stream you go down, the more you're going to start to hear about these things and they'll become more familiar. So the first time it might be a little bit overwhelming, but you'll keep hearing about it, you'll read about it, and more you'll absorb it, and you'll become more and more comfortable with it. And there is rarely a black and white. And that was a good question. And that's a good example of why it's not just black and white. There's a lot of gray, but understanding these concepts will then allow you to understand how to expand the concepts. Okay, looks like we're out of time. Just quickly, you've got the encryption device, which allows you to encrypt data leaving your network or within your network. And then you've got what are known as packet shaping or traffic shaping devices, which allows you to basically prioritize traffic. So let's say you're at your office, you might have a packet shaping device that is going to limit the priority of any traffic coming from YouTube or Netflix or Hulu or whatever. So it essentially allows you to constrain traffic that's going to cause congestion.